Okay, now we're just past 9 o'clock, so I think we'll go ahead and officially get started with the 2020 MSU Turfgrass Virtual Field Day. Thank you everyone for attending this morning. You can see there were some slides going by, and I'll cover some of that information just as we get started this morning. First of all, I'd like to welcome you, and my name is Kevin Frank. I'm a professor and turf extension specialist here at MSU, and this is our virtual field day. Of course, we've always had this field day in person in the past, but due to COVID restrictions this year, we are doing it virtually. So many of the videos you are going to see this morning were recorded earlier this summer. Following the videos, we will have an opportunity for Q&A with each of the speakers. So as we go through and you see the presentations, if you have questions at any time, please put them in the Q&A box, which you should find towards the bottom of your screen on the right. So there's a number of buttons down there, and you'll see a Q&A button. You can go ahead and type your questions in there, and I'll do my best to monitor those, and we'll have the opportunity to address those questions with our speakers once their video clips finish up. So the idea is we'll have 4 speakers or 4 presentations this morning, and an opportunity for a Q&A following. Before I get into too many more of the details, I would like to give this opportunity to our Department Chair of Plant, Soil, and Microbial Sciences, Dr. Brian Horgan, to give a couple opening comments on behalf of the department. For those of you that, many of you in the turf world probably know Brian. Brian was a professor in turfgrass science at the University of Minnesota before coming over to us approximately just a year ago. So Brian, go ahead.
Thanks, Kevin. Good morning, everybody. Thanks for taking some time out of your busy schedules for your continuing education. It's so important that everybody get a chance to decompress occasionally, especially in this crazy time, and soak in some new information, some new research. And our MSU turf team remains committed to delivering this research-based information that is both timely and relevant. And I'm very proud of the speakers that are here today and how quickly they pivoted from an in-person to a virtual field day. So I know you're in for a great morning. So sit back with your cup of coffee and enjoy yourself. And please don't be afraid to ask questions either today in this chat panel or to reach out to any of us afterwards. And we'd be happy to help you and answer any questions that you have. So Kevin, with that, I appreciate you giving me a few minutes here, and have a good morning.
Thank you, Brian. It's indeed a beautiful morning out there if we had an actual field day. So some of those that have attended our field days in the past, and occasionally we've dodged rain showers, today would have been one of those fortunate days when the weather was perfect. So I just want to give you a couple informational items as we get started. So you've seen some of these slides scrolling by, and I really wanted to have you acknowledge or thank all of the sponsors of the Hancock Turfgrass Research Center. We have a number of companies that donate products and equipment to us every year that really makes this facility run. You can see that slide as it just went by. Let's remind you a couple things. Once again, if you have questions, put them in the Q&A box towards the bottom of your screen. That would be helpful for us. If they do end up in chat, I'll also do my best to monitor that to see that we get those questions answered. Depending on how many questions there is a possibility that we won't be able to get to everyone's questions. If that is the case, we'll do our best to kind of archive those and then respond to those after the program. We can send you a link that would have kind of some of the questions and the responses from our speakers. At the conclusion of today's program, you will have an opportunity to earn your Michigan Department of Ag and Rural Development pesticide recertification credits. So this program has been approved for 1 credit in Commercial Core, Private Core 3A, 3B, and 6. All of that information will be at the end of the presentations this morning. You'll just need to fill out a little bit of a survey, and then we will have your information and we'll be able to submit that to MDARD to get your credits. So with that, I think that kind of wraps up what I wanted to talk about initially, and I will send it to our first presentation of the day, which is going to be Dr. Joe Vargas talking about some different disease issues in lawns.
And now we're into the home lawn athletic field disease portion of the presentation. And it's been really warm this summer, and I don't have to tell you that. And we haven't had a lot of the normal diseases that we get. Right now, in front of me here is a lot of dollar spot that occurred when the temperatures cooled off about a week ago. You can see the white patches, very typical of dollar spot. Normally this time of year we have red thread as well, but the temperatures have simply been too high. But I will guarantee you it's coming this fall, along with rust. You're going to have to wait until get into August or September at some cooler temperatures, but you will see red thread and you will see rust in addition to the dollar spot. Over there in the background is a disease called necrotic ring spot caused by a soil-borne pathogen. And it's been prevalent this summer as well because of the extreme heat. When fungus damaged the root systems, the plants began to wilt and die. And it's mostly the case with Kentucky bluegrass type turfs. The key to managing diseases, or at least limiting diseases, is daily irrigation and having adequate fertility. And this is a low fertility area here, so we have a lot of dollar spot. If it continues into the fall, we will also have a lot of rust under low fertility conditions. And necrotic ring spot that I pointed out over there definitely is greatly reduced by the use of both fertility and daily irrigation.
Okay, so that's a clip from Dr. Vargas. I think we're having some difficulty getting Dr. Vargas on the line this morning. So I don't know, Nancy, would you be willing to have a little conversation with me about diseases and home lawns? You're on mute, Nancy.
Hi, good morning. Yeah, sure. Joe is actually on. He's actually just on as a as an attendee. So I think if we can unmute his mic, we'll be able to get him on.
Okay.
Nancy, what's he listed under?
I'll text you what he's under.
Okay.
So I'll just start the conversation while we're waiting for Joe here, because I think he'll be on in just a moment. Joe talked about some different diseases, especially as we got into August, and now of course we're well into September, almost approaching October. And I know the things that I really have noticed now in the last couple of weeks from a home lawn standpoint, or just higher cut turf, whether it's athletic fields or home lawns. As Joe had mentioned, certainly red thread. Red thread's been around, but I think this time of year, especially now, rust becomes very prevalent. We have been dry now after a little bit of some good precipitation in early September. We're in our second week of really dry conditions, and it looks like that's going to persist at least through the rest of this week, or this week and maybe early next week.
I can't even get on. I'm on my phone. It says I'm an attendee. My mic is.
Nancy, you might want to mute until you get him on officially. Sorry about that. So certainly seen a lot of rust with the dry conditions. I think some of that also pertains to, just from my perspective, we often see at this time of year many sites where maybe they haven't had did they do an early September fertilizer application, or maybe a late August, or are they still waiting to get that application out? So when you come off the summer we had, where we had some extended dry conditions, some very warm temperatures, and then followed that up with this dry period in September, once again, seems like kind of the perfect scenario for rust. And I know just from some personal observations and looking at the Kentucky Bluegrass NTEP trial that is here, which I think has, I think it's either 88 or 89 different entries of different cultivars of Kentucky Bluegrass, that some of those really get hammered with rust and others are literally untouched. So for many of the sites you might be managing, it could be not necessarily anything that you're doing wrong from a cultural standpoint or a management standpoint. It's just simply that you might be dealing with a cultivar that is just very susceptible to rust. That may kind of change your management approaches a little bit, or make you have to pay a little more attention to that. Nancy, is anything that makes sense to you? Do you agree, disagree, or what do you think? You're on mute.
Okay. Yeah, Kevin, actually, you're exactly right. So some of the diseases that are really starting to pop right now are red thread and rust, especially in the home lawns. And in fact, I'm teaching class right now, and I have some beautiful videos that I've shot recently for class to show that. And in terms of rust, the pathogen is race specific. So if you happen to have certain cultivars of Kentucky bluegrass that are highly susceptible to certain races of rust, you're going to have a lot of problems regardless of, you know, what you're doing otherwise. You know, your next door neighbor who might have a different type of grass or a different cultivar of Kentucky bluegrass, they may be doing the exact same thing as you and may not have hardly any rust. And so it is very race specific. That's a huge factor in whether or not you have a rust issue to deal with or not. One thing about rust is that it's what we call an obligate parasite. So it needs to have a living host to survive and replicate. As you get into rust, if we get into that season, if you can, you know, when you mow, try and remove some of your clippings. Actually, no, that's more for red thread, sorry, not rust. But that's a good management strategy for red thread as well, because those threads that you see for red thread, when they break and kind of spread, that if you can remove that from the turf when you're mowing, you can reduce the spread of some of that inoculum that are in the stroma that are spreading from the red thread. So that's a good strategy as well for that. Low fertility tends to really bring on both of those diseases. So if you can maintain fertility levels, we often see both diseases and also leaf spot much worse in areas that are under low fertility, and you'll get some dollar spot in there as well. That tends to be one of the major issues with a lot of the home lawn diseases.
Nancy, we often talk about this, and I know Joe referenced this in his video clip of kind of like low fertility or adequate fertility. Could we, from a pound of N standpoint, what do you think like low? Are you thinking like 1 to 2 pounds N per year versus adequate, maybe on most, especially Kentucky bluegrass lawns, maybe closer to 3 to 4 pounds N?
Yeah, so from a disease management standpoint, we like to see it up closer toward almost a pound of N a month, a half pound to a pound a month. So we're looking at probably 4 to 5 pounds a season. And again, that's from a disease management strategy. When you get less than that, the turf isn't growing as vigorously. So even if you have a disease, if you have the turf that's growing vigorously and is healthy, then a lot of times the epidemic, the infection won't get as severe. You may not notice it as much. And so by having a slower growing turf with lower fertility, lower nutrition, you're going to see a lot more damage. The pathogen is going to have more of an advantage. And so you're going to have probably more severe infections and outbreaks.
That makes a lot of sense to me. I think often too, what we look at, especially in the lawn care arena, is a lot of lawns that are being managed on very poor soil. It's very, you know, disturbed suburban, you know, sometimes you're left with the clay that might have been a couple 10 inches or so down and the topsoil is kind of gone. So those sites, I think often it's very easy to get some of these diseases popping up just because the soil isn't supplying much. And if you're not really on that kind of adequate or, you know, 3 to 4 or 4 to 5 pounds in an annually type program, those diseases might become more prevalent in those types of situations, I think.
Yeah, that's a particular problem, especially with necrotic ring spot. We often see that disease break out where we have sod laid on poor subsoil. And oftentimes we might see it in areas that are new subdivisions, for instance, where they scrape off the topsoil and they might just put a teeny bit back before they lay the sod back down. And then everything looks great for the first couple of years. Then 3, 4, 5 years down the line, all of a sudden, you see necrotic ring spot breaking out all over the place. That's a very common way when we see real severe outbreaks of necrotic ring spot. That's a real common way of that occurring. What we recommend in that case, like Dr. Vargas said in the video, is adequate fertility and light daily irrigation. With that particular pathogen, the roots are being infected on the plant, and the infection begins in the cool, wet weather in the spring and the fall. So back in the spring, if it's midsummer and you see all these dead rings in your grass, that means back in the spring you had an infection occurring, and you probably weren't really aware of it. And so one of our recommendations then, if you in the middle of the summer have this grass you have all these dead rings, you want to try and alleviate the stress that it's under because they have damaged roots. So that light daily irrigation helps to alleviate some of the moisture stress. The fertility also helps to alleviate some of the stress on those plants. So when we did research years ago on this, we found that the light daily irrigation in combination with the with the fertility, manage the disease as well as a fungicide. So that's really important, especially with necrotic ring spot.
Nancy, we did have one question come in. Let you answer this instead of me. In a residential lawn, would you treat dollar spot and red thread with a fungicide, or just make a fertilizer application and let it run its course?
So if it's on a home lawn and you have both red thread and dollar spot together, which is very, very common. I have both of them where I've been doing, like I said, video recordings. Typically you can get by with fertility. If it gets to the point, if it's a real severe outbreak and conditions aren't going to change, so that's another thing you have to keep in mind, you may need to put an application down. I would think that you could get by with fertility. So when I mentioned something about conditions, so for disease to develop, you have to have the right environmental conditions. If temperatures are going to change here in the near future, it would kind of be a waste to put a fungicide down, because once the temperatures, once we start getting hard frosts, that's going to really change the ability of the pathogen to infect. So kind of look at the timing, look at what the temperatures are going to be. Is this going to continue to be, a conducive environment? Now, if this was the very beginning of the time frame when you can have this disease going, and it's pretty severe, you may want to put some fertility down and a fungicide. But if it looks like you're kind of mid or toward the end of when you have conducive environment, then you probably can get by with just fertility.
So like right now, just to wrap this up, I'm thinking of, it's going to be quite warm the next couple of days. And I saw the forecast going into next week. Looks like we're really cooling off. So if you have dollar spot or red thread in your lawn right now, what do you think? Just let it go?
I warm. What are the nighttime temperatures? I'm not exactly sure.
I mean, it's highs near 80, I think, for a couple of days. I'm not positive on the nighttime.
Yeah.
Next week, we're highs in the low 60s, I think high 50s or something like that.
Yeah, so once we get down, down below, I mean, those are still, that temperature range 60 to 80 are still okay for both diseases. And it's when we get the night, the other night we had 32 where I was as a low. That'll be a game changer there. But the daytime temperatures that you mentioned are still pretty good for those diseases.
Okay, excellent answer.
Hello.
Hi, Joe.
We're gonna have to move on to our next presenter, which is Dr. Trey Rogers, and Trey is going to show us. We're going to see a video on some of the interesting athletic field research that is now being undertaken here at MSU.
Hi, I'm Trey Rogers, member of the Plant, Soil, and Microbial Sciences Department here at Michigan State University, Turfgrass professor. I'm going to talk to you today about a project that's been around a while. We started this project in the year 2000. Myself, Dr. Jim Crum, and graduate student at the time, Jason Henderson. And what Jason wanted to know was what kind of differences did we have among athletic field systems. So what we have here is something that was built in 2000 that had 15, at the time, 15 of the leading athletic field systems in the United States and the world. Jason graduated in 2003, but we left the research right here. So now here we are in 2020, and we kind of wanted to dig it up, see what we have, see if there's turnips underneath there or something along those lines. But no, we wanted to dig it up and see how these systems had aged or matured over time. Now, what's interesting here is we try to use some quantitative measures, things that you might be familiar with, like a Clegg shear or a Clegg hammer. But we also have a relatively new piece of technology that's going on in the background here called a going stick. And Dr. Thomas Green, newly minted Thomas Green, a postdoc here with us, is kind of demonstrating the going stick. And our objective over the next few minutes, let you see the kind of differences that we have. Our plans are also to let you see some work we're doing with the University of Kentucky, because one of the things that they have is the ability to simulate a horse's hoof. And we are now learning that the horse industry would really like to race on turf, as that's their safest surface. So they want to increase the number of races across the United States. This is a way for us to help that industry because of this athletic field system for them to gather some data very quickly.
When the OBST strikes the surface, it's replicating the forces seen in the horse's front forelimb. So it's actually striking the surface with about 2.5 times the body weight of the horse. So today we have an array of sensors on the OBST so we can measure these forces and accelerations that may be seen by the horse.
With this particular study, we are looking at different soil compositions underneath the turf grass and measuring all of these plots with industry standard tools as well as a biomechanical horse hoof with the intent of observing differences between the plots. The goal is to make this safer, less catastrophic breakdowns for horses, less injuries for jockeys. That is the ultimate goal of this research, is to improve the safety of the sport.
This type of research is important because it further develops our understanding of the surfaces and the hoof interactions, which is not as well understood.
There's been a lot of research done on turf grass safety of other sports, football, rugby, baseball, etc. A whole ton of turf grass research in golf. There's been a lot of horse racing research done on dirt and synthetic surfaces, but the two worlds haven't collided yet, if you will. Turf grass for athletics and turf grass for horse racing. Dr. Rogers reached out to my advisor, Dr. Mick Peterson at the University of Kentucky, and Dr. Rogers had an interest in particular in horse racing, but had done a lot of turf grass research, none of which had yet been applied to horse racing. And lo and behold, Mick said, actually, I have a really good opportunity. I have a PhD candidate looking at this very thing, so we'd love to work with you. And that's kind of how this whole thing became about.
This data was recorded at the Hancock Turfgrass Center over a 2-day period back in August 2020. The graph on your screen displays cushioning values data from the Orono Biomechanical Surface Tester, or OBST for short, for 2 contrasting sand-based root zones at varying moisture levels. The blue line is from a well-graded sand, and the yellow line is from a poorly graded or uniform sand. While these preliminary results depict both soil moisture and pore space controlling the values, it also shows the ability of the OBST to pick up these differences, a very encouraging sign.
All right, Dr. Rogers. So I have one question right off the top. I'm not sure I heard it correctly. What exactly is a going stick?
So what you're seeing there is that going stick is kind of has been manufactured from an old idea. If we go back 40, 50, 60, 70 years ago to racetracks in Europe, primarily in England, the old way that they used to measure the condition of the track was a track manager would take a long stick and simply walk the track and stick the stick in the ground, kind of see how hard it was and how well it gave. And the question they would ask him, race people would always ask him, was, how's it going? So there was your going stick. So, I'd love to tell you it's all fancy and, and of course, what this machine has done, this turf track machine, is just kind of tried to quantify what someone who maybe had 50 or 60 years of experience on a track, not a whole lot different than what we've been doing the last 40 years, quantifying someone's experience.
Excellent. That's very helpful. I like that. How's it going? I've thought about that a couple times this morning as we've got these presentations rolling. How's it going?
Well, I can get you a stick. I can get you a stick.
So what are some of the, as referenced in that video clips, the different athletic field systems that were tested back in the early 2000s, and kind of, I guess maybe just to the attendees, kind of like what is the overall objective, or what are you looking at? I mean, some of the, maybe even describe it, just a couple of the systems you're looking at out there.
Sure. When Jason basically there were two types of systems. One is when this went in, this was kind of the beginning of the inclusions, and there were about 3 carpet companies that were basically laying down carpet, and we see it now, and it's a little bit before the crumb rubber was, the synthetic turfs were coming along. So that's one type of system. You'll hear it called Hero, you'll hear it called Eclipse. It's pretty popular in Europe now. So we had the first iteration of that. Those really are, they're okay, but they've decomposed over that 20 years. What really hasn't changed is the other side of these treatments, which was add a little bit of silt and clay, a little more silt and clay, quite a bit of silt and clay. Compare that to a very loose sand, compare that to a well-graded sand. Also include some of these things like Zeopro and some of the other ingredients, inert ingredients that are going on there, all on the same grass, and see if we could kind of compare that. So after 20 years, you really wanted to see, had anything changed? And the idea was kind of floating around in our head as, you know, could we measure this? The University of Kentucky kind of showed up kind of as a bonus, and we were a real bonus to them because they've got some new machines. They'd love to see what can it measure, and we know the differences in these soils, and we can measure it. So it's worked out real well. You like to say, well, is there anything real new? No. If you watch the Raiders new football game, that football game in that brand new stadium, that field looked fantastic, right? I mean, but one of the things that it had up in the top inch was this thing called turf grids, which is small fibers. And those small fibers really hold that soil together. Well, that's one of our treatments. So it's been around a long time, so it's not anything new. We're just trying to see, what we were trying to see was the longevity of some of this. What kind of numbers, how'd they compare now to what they compared in 2003? Hope that answers your question, Kevin.
It does, but of course you created another question for me. So when I was watching that Monday Night Football game from the new Las Vegas stadium, that's a dome, correct?
That is.
So are they growing that field in there? Are they moving it in and out? How's that working there?
So that feels a lot like Phoenix. It's just a takeoff of Phoenix, and I was involved in both of those, but the one in Las Vegas is basically Phoenix improved. We went down to Phoenix where the Cardinals were and said, what would you like to do different? What would you like to do better? They're very open about it. And, made some subtle changes, nothing that the viewer would be able to see. But yes, that field's going to come in and out. And underneath that field is an artificial field that they let the colleges play on. I'll just leave it at that.
Well, I didn't know that. That's pretty interesting. That and the Raiders actually look pretty good if you watch that game. So just wanted to acknowledge, I don't know if Thomas, if you had anything to say about this study, or if not, that's fine. Also, just wanted to give you the opportunity. I know we'll see you presenting in the golf section coming up later this morning. So I think we will go ahead and transition to our next speaker, which is Dr. Tom Nicolai. Tom will talk about some best management practices and some weed control studies, I believe.
Welcome to the Hancock Turfgrass Research Center Virtual Field Day. Well, at least virtual for you. I'm here. The Hancock Turfgrass Research Center is one of the premier turfgrass research centers in the entire world. It was all started by this guy, Robert Hancock. He wanted to dedicate his money and life to promoting turfgrass research for the betterment of mankind. And some of the greatest experiments ever in the history of turfgrass science have come from here. But let's face it, here's what you're thinking. What have you done for me lately? Well, that's what Field Day is all about. So maybe we should take a look. Besides Robert Hancock, this place still wouldn't be here without dedicated individuals such as Mr. Gordon LaFontaine, who is the executive director of the Michigan Turfgrass Foundation for years. We've had lots of support over the years from industry, and I'd just like to start off by thanking all the board members over the years that have kept this facility running and is literally the envy of the turfgrass research world, basically because of your efforts. I really like these experiments that you can walk out and you just look at them and go, boom, something's happening here. This is one of those kind of studies. What I've got is a turf type tall fescue here. Looks kind of beautiful, nice, lush. You can see it's cut down in the alleyways here. And this is really kind of born out of like the idea of best management practices and biomass production. What we've been doing here for, well, this is now the second year of this study, is we've been taking and figuring out through TDRs the different amounts of moisture that is being in the soil based upon grass grown at 3 inches, 2.5 inches, or 2 inches, and we're weighing biomass. From other studies we've done on putting greens, we know that the lower the mowing height, the more clippings above ground that are produced. The thought process was, well, maybe there's a point of diminishing returns where that doesn't happen anymore. Here on these plots, and these are irrigated, they look absolutely beautiful, but we're getting the same thing. The lowest mowing height, all the way from down to 2 inches up to 3 inches, on like every occasion, is giving us more biomass. So maybe part of the take home is, if we can mow a little higher, we're producing less clippings and then leaving less on our lawns or roughs, or think about any other case like that. This is another one of those beautiful studies that it's easy to see that something's going on. While often we spend time with selective herbicides, this is non-selective herbicides, and we're thinking about establishment here. If you look over here to the right, it's easy to see that we're killing the grass, and right here we've got a beautiful lane, and again we're killing the grass. What we have are two different very popular products. One over here is glyphosate, or otherwise known more popularly as Roundup, and over here is glufosinate, or more popularly known as Finale, or for those of you in agriculture, they might call it Liberty Lynx. Same active ingredient. These plots right here were sprayed 9 days ago. So 9 days ago, we're seeing what it looks like 9 days after treatment. If I move a little bit more forward, these are sprayed 7 days ago. So we can see that both being very active. If I move a little more forward, these are sprayed 5 days ago, and this is where we really start to see that the glufosinate, or Finale, is working much faster than the Roundup, which is a systemic, okay? If I move one more plot forward, these were sprayed 3 days ago, and this starts to show us how fast acting this Finale can be as compared to the glyphosate. And if I go one more plot forward, they were sprayed yesterday. Now what we're gonna do in 2 more days is I'm gonna come in and we're gonna mow this down as tight as we can mow it, and then we're gonna slit seed perennial ryegrass into it and see and count the establishment using these different types of non-selective herbicides. Kind of exciting, isn't it? Oh, wait a minute, you have a question? That's a good question. Sure it is. The question was, for those of you that couldn't make it out, was, well, what if you tank mixed glufosinate with glyphosate, and by mixing them, would you get a quicker kill and a longer kill? And the answer is no. It's a really good idea, except for the site that the glyphosate kills in the plant, the receptor would be kind of shut down if we use the contact right away. Very good question, but no, don't tank mix these two non-selective herbicides.
All right. So Dr. Tom Nicolai should be on the line with us here. Tom, I can't see you yet.
I'm you can hear me, right?
Yep, I can hear you just fine.
I'm trying to find a way. I'm looking, hold on, to share my screen. Hold on. Start my video. Oh, look, here I am.
Yeah,
Wow.
there you are.
And then share screen here. Thank you. Let's go to the beginning. Okay. So far, so good. Kevin, am I doing okay?
Yeah, I have no idea what you're doing, but you're doing great.
All right, thanks. I want to finish up on the two studies that I just showed you and talked about out there at the field day. Thanks to the two people who went before me. Sometimes we don't always get to see what everyone else is doing at the Turf Center, especially during the year of COVID. So I very much enjoyed the first two presenters. If I go back to 213, and we're talking about this height of cut study I showed in the clipping. And we go back to 213. It was the first time I was doing this type of research and seeing that the up here, the tightest mowing height is always giving us the most amount of clippings. And the first time I saw that, I was kind of surprised, but I probably shouldn't have been. And I probably shouldn't have been because it just makes sense. The plant is trying to grow deeper roots at this time because there's so little above ground plant. And if we really look at this and compare this highest mowing height, this is of course a putting green, we compare that to the really tight cut, always the tightest cut is giving us the most clippings. When you think about this, however, when I'm doing this study, I'm doing this with 9 different mowers. They're extremely, the differences in mowing heights are very small compared to a lawn. And so to try and gauge everything in, there's probably a little bit of slop in that data. If I go to the lawn studies that I showed when I was walking around the Turf Center there a moment ago, and this is from 2019, and we did this irrigated lawn study. And again, if we look down, we have 3 inches, 2.5 inches, and 2 inches. Wherever we irrigated the most, or I'm sorry, the lowest mowing height is always producing the most biomass every single time. Amazes me. So in 2020, we decided we wanted to do it again, and we did it on both irrigated and non-irrigated plots. So when I'm doing this on irrigated, non-irrigated plots, I'll just show that data for now. Again, we have 3-inch mowing height, 2.5 and 2. And again, this is a beautiful turf type tall fescue. And I want you to look here. We have 2 inches, and these differences in the amount of clippings, the amount of biomass that's being produced are significant. And unlike when we did this on a putting green and we had 9 different mowers, these numbers are probably even more truer about how different they are because all of them were mowed with 1 mower. It's very easy to take a walk behind mower to collect clippings and set the adjustment so they're all coming from the same mower. Very easy. If I get a bird's eye view and I look down at these plots, this is what they look like. Like I said, I love studies that it's easy to see something's going on. So here's our 2-inch height of cut. Here's our 2.5-inch height of cut. And here's our 3-inch height of cut. Now, we know from lots of studies that have been done for 20, 30 years that the higher the height of cut, and if we fertilize and stuff like that, the better chance we have of keeping disease pressure down, weed encroachment, and they stay greener longer. But in any event, when we look at these different mowing heights, our average, if I took and I put all those grams from all the mowings for the entire year together, and my annual average, if I raised my mowing height to 2.5 from 2, I basically end up with 2 times less the amount of clippings, just that small amount. From our study, when we raised our mowing height from 2 inches up to 3, we're almost to 3 times as less clippings. That's significant potentially from a if you're a lawn care operator that mows and you can get your customers to raise that height a little bit, it might leave less clippings behind in the long run. Certainly good for a homeowner standpoint. Don't get as much clipping debris on your lawns as well. So good food for thought, especially if you're only trying to mow once a week, which is what we were doing in the study. Pretty significant. Another study we chatted about was the selective or non-selective herbicide study, and this is a bird's eye view of this. So this is like 10 days after treatment, 8, 6, 5, and so on. And we're seeing that the glyphosate or Roundup takes longer to work. Of course, this strip is where we did nothing. We allowed this all to take place, and we waited to 12 days after the initial glyphosate treatment. And we went in and mowed it down, and we slit seeded in. We come back September 11th, and it's pretty obvious. Here's our Roundup. Roundup's doing a fantastic job. Why? It's translocating. It's going down. It's killing the roots. It's awesome. This would be our check plot. It looks fine. And this is where we use the finale. Now, we've got some ryegrass growing in here. But obviously, since it doesn't get to the root of it all, it's not really killing the plant. This is taken 2 days ago. This is the glyphosate or Roundup treatments, and you can see none of that. Literally right now at this point, there's none of the tall fescue coming back, and this is all the ryegrass growing in. And here we are looking at the finale, and it's primarily it's coming back, the turf type tall fescue, all because of the fact that the finale can't kill the roots. But finale's awesome for other reasons. Edging for one, and we're doing some other studies with it as well, trying to take Poa annua out of Kentucky bluegrass on sports fields. This is what it was looking last year, and we kind of went through early spring last year into early summer, trying to take the Poa annua out of the Kentucky bluegrass, and really weren't getting much. But I made a late fall application last year. Here it is underneath the snow. This is March 1st this year. And lo and behold, what we're starting to find, and we're going to look more into this coming year, fall with rates, is if you see on the right, there's a lot more Poa annua in it than there used to be. And it's basically because the finale is really kind of helping to stun it. We also looked at this year, we also did some studies with broadleaf weed control and late summer, trying to kill these hard to control weeds when the cuticles are really thick, and had some great success with some of these pesticides or herbicides. We also did some pre and post crabgrass studies. Awesome stuff. And what I'm going to do with this stuff is we'll type up all the results. And what we do every year is we get them out. And when we get them out, I want to do a promo for this. This book is called Turfgrass Weed Control for the people that are watching right now, for professionals. It's put out by Aaron Patton, Dr. Aaron Patton. 16 states are involved. Somewhere down here in very, very small print is my name, because I actually collaborate and put in my research, and we all meet once a year and chat about it and update this book every year with all the newest stuff. It has everything you could possibly want to know about weed control in the Midwest. It has 100 different weed species that you can look up, how to control them. It's a fantastic book. And I want to leave this up there for a minute. You can order it online by going to this website. And it's really a must-have for any turf professional or any homeowner, because you have basically the brightest minds in weed control, weed search, from Nebraska to Maryland, okay? And all put together by Dr. Aaron Patton, who is just an awesome person. With that, if you have any questions, I want to give you my email, nikolait@msu.edu, or you may want to text me or call me. And when I type all this information up, which really won't be till about December, we'll get that out to you, the data that we collected this year, and hopefully it can help with your profession. With that, I've allotted my time, and thank you very much.
Thank you, Tom. Could you just stop your screen sharing, and then we have one question that has come in for
I'm
you.
going to try and stop my screen sharing. I got to find it. I know. Stop share. Got it.
There we go. Perfect. Thank you. So the question was, what were the mowing frequencies in the height of cut studies?
If I go all the way back to the putting green, it was daily. If I go to what we were doing this past 2 years, it's once every 7 days.
Okay. I had one question for you that really caught my eye as I know you had a lot of information, a lot of different studies there. The finale, so you're spraying Kentucky bluegrass with finale with the idea that you're going to take out the POA and not the Kentucky bluegrass? Is that right?
Yeah, we're at different rates. Great question. We're at different rates. The lightest rate, you can barely see anything. The highest rate, it looks kind of like the study I showed from above. It basically looks like it's dead, but it's finale. It's not going to get to the root of it. And so what happens is the annual bluegrass, and what it appears to be, especially in the late fall, it just gets stunted back far more than the Kentucky bluegrass. And when we came back this past spring, the Kentucky bluegrass had really filled in a lot. And I just kind of threw that out for fun last year. So this year, we're going to kind of hit a couple different dates at a couple different rates and really watch that. The idea being that if it's a soccer pitch and it's late in the year, the season's over, or potentially a football field, to try and knock out and give that effect so the Kentucky bluegrass can fill in if we can hurt the POA a little bit.
That's a really interesting concept. I mean, so you could think of, I could see how the POA could get hurt or killed, hopefully, and the bluegrass, if nothing else, gets dinged or just regenerates from rhizomes, possibly, I guess.
Yeah, I think so.
Cool. I don't see any more questions. So, Tom, thank you for your time. We appreciate it. And next up will be me. So I've got a couple videos. We'll pause between them, but the first one is on some nutrient fate work we've been doing here for many, many years now. Okay, so I guess I could answer my own questions or ask myself questions if that's the way I should do it. Just give you a couple little details on that study that I didn't necessarily give you the specifics on what I was talking about in the field. So the lysimeters, they've been in place since the early 90s, and then we started these treatments when Dr. Jim Baird was here in the late 90s. He started putting these back out, and then when I started in 2000, I've kept this going now for the last 20 years. And when I referred to the high nitrogen rate, we were looking at 5 pounds of N per 1,000 square foot split over 5 applications annually. And that went from 98 through 2002. And that's where we saw tremendous amounts of nitrate N leaching through. We would see somewhere on the order of 3 to 4 times the EPA threshold on drinking water quality, which put us around 30 to 40 parts per million for several years. We backed off that high N rate back to 4 pounds of N. Starting in 2003, and we kept that going through approximately, I think it was 2016 or 17. And then just last several years, I went back and looked at that 5-pound N rate again. So when we were doing the 4-pound N rate, the system really stabilized. We didn't see high levels of nitrate N leaching at all. The only exceptions, as I mentioned in that video clip, is sometimes still during the dormant season when we're not frozen here and there's still water moving through. So it's ability to move nitrate N through, so turf isn't taking anything up. But then we started back the 5-pound N rate about 3 years ago, and I've seen a slight uptick, but nothing even close to what we saw in the late 90s through early 2000s. So we'll keep monitoring that. The low N rate has been consistent. It's been 2 pounds of N annually over the entire course this trial for 20 plus years now. And we've always, without exception, there's been, I think, literally one data point over those 20 some years has been over 5 parts per million. So everything on the low N rate is almost negligible what moves through. So that's kind of where we're at with that project. We continue to monitor it. And as long as the lysimeters stay intact, because some of the infrastructure you start to wonder about after an extended period of time being in the ground, not the lysimeter itself, but just kind of those entrance chambers that you saw that we climbed down into to gather the samples. So I think that's where we're always a little bit of a compromise, myself from a fertilizer or nutrient fate standpoint, versus when Nancy and I were talking about some of the end recommendations for diseases. It does depend on site, it does depend on soil, but generally, at least on our soil here, we found there could be issues when you got to those real high annual N rates of, let's say, 5 pounds N plus on our site. So I don't see any questions related to that, but if there are some that come up, I'll be happy to answer them. So the other video clip I have that we will play now as we kind of start to wrap things up for this morning is a video on one of the NTEP studies that we have. This is the last year of what is called this low input cool season test. So we'll look at that video and then talk a little bit about some of the different species that are in that video when it concludes.
Hi, I'm Kevin Frank, professor and turf extension specialist here at Michigan State University. Today what I'd like to talk about, this is one of the National Turfgrass Evaluation Program trials we have here. This is the 5th year of this trial, so this is the final year. This is the low input cool season test. The thing that's been unique about this trial is where a lot of times we have these trials where we're evaluating cultivars for performance, maybe on, for example, putting greens or on high maintenance athletic fields. This one is truly low maintenance. Since it was established 5 years ago, this has had no fertilizer, no pesticides, no supplemental irrigation. So what you're seeing here is how these grasses perform under literally the lowest maintenance. Only thing they're getting is mowing. So when we look across kind of this whole plot area, we had a pretty hot start to July. We were very dry. We've just got some rainfall in the last couple weeks down. You've seen some resumption of growth from some of these plots. However, some of them are still a little bit dormant and struggling, which you might expect. For example, this plot I'm standing right next to here, this is a northern mixture, which is primarily perennial ryegrass with some Kentucky bluegrass and then some of the fine leaf fescues also in the mix. You can see right now it's still primarily dormant. It hasn't rebounded yet at all. Not necessarily a bad thing, but just gives you an idea of what it looks like when we're going through some of these more stressful hot periods. The one right behind it here is probably familiar to a lot of people, Kentucky 31 plus endophyte tall fescue. Now this is one that we often kind of not make fun of, but we look at Kentucky 31 as a very coarse textured wide leaf blade tall fescue that we don't necessarily recommend in many situations. But you can see it's doing quite well when you look at the overall density of it, and it's even resumed some growth with that rainfall, like I said, we had in the last 14 days. As I go across to some of the other plots, we'll show some of these in more detail. One that I think is kind of interesting, this has been an interesting study because we look at not only our traditional turf grasses, but you look at something like yak, which is a yarrow. How do I look at it? Well, at this point, it doesn't have bad ground cover, so it's somewhat acceptable. However, you can see, I think, compared to some other plots, it is a little thin. The rainfall really helped it. It doesn't survive, or it doesn't persist growing during those really dry conditions. When you compare it to some of the other fine leaf fescues that we have in mixes here, whether it's a CS mix right behind me here, and we'll show some of the specifics of what are in each of these mixes. But the density on this is quite impressive when you consider for 5 years it's had no inputs beside mowing. Still has some pretty good green color, resumption of growth, a little bit of hot spots, so to speak, from that drought. But then another one, when you look at just how the cool season grasses compare. So this is a natural knit perennial ryegrass mix. So it's 100% perennial ryegrasses. And probably the biggest contrast I see just when I look at these plots is not only the density between the perennial ryegrass on my left and the fine leaf fescues on my right, but also notice the weed pressure. I literally think there's maybe one weed in this fine leaf fescue plot, and in the perennial ryegrass plot, you know, it might be 30–40% weed cover at this point. So kind of the bottom line is, you know, when you look at some of the very low maintenance aspects of this trial, there's two things that I think we've seen over time of this trial. And one has been the fine leaf fescues generally have performed very well, especially under the low inputs. And if I were to follow them with price second best, it would seem like in our conditions, the tall fescues have done pretty good. Those grasses are going to be different in how they respond, depending on the amount of moisture and the heat. But at least in Michigan, those two seem like they're the ones that have done the best under these very minimal maintenance conditions.
Okay, so that was, like I said, that was a low input cool season test. And that's been an interesting trial now as it wraps up in its 5th year. One thing that I didn't really even show in that specific video clip, in addition to just the normal kind of what we call the turf grasses, whether they're the fine leaf fescues or the tall fescues, Kentucky bluegrasses, some perennial ryegrass in there. It surprised me as how relatively clean from weeds that most of the trial stayed over the course of this. And I think part of the success to that, so to speak, was over the last 5 years, we've almost without fail had at least one period during each of those years where we had very dry conditions. So it really prevented things from like clover from completely taking over the stand, because some of those plots even were seeded with some clovers, some micro clovers, to try to see about creating maybe a sustainable stand where you don't have to fertilize as much, because the clover is a legume and can provide some nitrogen to that turf grass as it grows alongside. And for our plots, they stayed relatively clean. Probably the biggest challenge I saw in the plots was that that yarrow really creeped into some of the surrounding plots. So the yarrow was fairly aggressive in creeping. The only thing that kept it in check, once again, was those dry conditions. When it was really dry, it really checked out and then rebounded later. So I did have one question that was circling back to the nitrogen fate study. He was asking about differences in weed invasion between the low and high N rates. Now, that was something I really wasn't able to monitor, because we have sprayed that area for broadleaf weeds over the years, just so I didn't want to get to the point where, whether it was for the low end rate or the high end rate, I was more looking at nutrient fade in dandelions than I was in Kentucky bluegrass. So that's kind of why I can't really comment on that. Generally, you would consider that at the lower end rates, especially if you're on a poorer soil, which is not something I would describe as our soil out here at the Turf Center, where you can see some weed invasion, and that would affect the turf grass quality between those low and high end rates. So just to wrap up on that last trial, low input test, I think in general, when you're looking at very minimal maintenance sites, like I said on the video clip, I think the fine leaf fescues do very well. They are gonna, especially some of them are gonna brown out a little bit and maybe a little slow to recover from a very dry and hot period. But if they don't have traffic at all, so if they're truly like kind of out of the way, maybe industrial sites or areas where there's just no foot traffic at all, there's certainly a very good option. And then I also think tall fescue does very well in the state of Michigan. Probably the only thing that I think really holds it back a little bit is tends to be a little more susceptible to snow mold, is what we see coming out of winter. And then you can get some brown patch in some hotter years. But once again, for low maintenance sites, even for irrigated lawns, I think it does perform very well. So we're right at 10 o'clock. That concludes our videos. I don't see any other questions that have come in. If you do have questions, you can feel free to contact us. I know my email address is frankk, so that's my last name and first initial, so frankk@msu.edu, and I'll be happy to try to sort through any questions. Once again, I want to thank all the generous donors of the Hancock Turfgrass Research Center, and a special thanks also to Jesse Scholl and Adam Palmatier are, Jesse's our Turf Center manager, and Adam, who actually just left us, but he was our irrigation technician for several years. Thanks for all the hard work they do out here to make our lives easier for putting the research trials out here at the Turf Center. So I think what we have at this point, there should be a survey that you click through, RUP information. Here's the feedback survey. That's where you need to go to get your MDARD credit. So we will leave that on the screen. I'm not sure if it's possible to actually click through on that when it's on a Zoom screen. I'm not technologically savvy in that way, but that is your information. You'll get 1 credit, MDARD pesticide research credit. So there, maybe just put that in the chat box. That is where you can click through. So look for your chat box. That has a direct survey link so that you can click through and get your pesticide recertification credits in Commercial Core, 3A, 3B, or 6. We will keep this open for a couple more minutes. If anybody does have any questions, several of the presenters are still on the line. So the question just came in, and I'll do my best to answer some of these. I'm not expert in all turf topics, but have experience, like most of us do, in answering a lot of these different questions. So question was, we had bad sod webworm in the Great Lakes Bay region. Has this been statewide? So the answer to that, here's what I've noticed, and this is kind of just around this area especially. Yeah, I think there was a lot of sod webworm activity, but I also noticed, and keep in mind, I'm not an entomologist, so this is kind of what I've learned from the entomologists and observed over the years. I've also noticed a lot of this last year bluegrass billbug injury. And in some cases, I think we possibly, as turf managers, we really identify or focus on sod webworms, because right when you're mowing, you're seeing all those moths kicking up and you're thinking, wow, this is all sod webworm damage. But in fact, in some cases at least, it isn't the sod webworm doing the damage. It might actually be another insect like the bluegrass billbug. So you see a lot of these areas, and where I really notice it is on, we had a lot of this type of turf where it was stressed from both heat and drought this summer. And even under irrigated conditions, a lot of people just, when we were pushing ET rates of, for this region, which were very high, of 1.3 inches a week or something on that order, people just weren't adding enough water back. So those lawns that were irrigated were still getting stressed. And when we came out of the stress, let's say late August, early September, and you had areas, especially if they were unirrigated, that didn't green back up. I saw a lot of that being bluegrass billbug injury. So that's something to keep in mind too. So correct diagnosis certainly helps, and doing that soap test where you put some Dawn dish detergent soap in a bucket of water, douse the site, and then look for what's going to emerge after, let's say, 5-10 minutes to try to identify the insects that are a problem. So the answer would be, yeah, I think we've certainly seen some of that damage. I can't speak for kind of like a statewide assessment of it though. Like I said, we'll stay on for a couple minutes here. Feel free, if you have more questions, put them in the Q&A. We don't have any questions. We'll start to wind down here in a couple minutes. Yeah, so for GCSAA, I had a question on that. This session is not approved for GCSAA education points. That'd be the 11 a.m. golf session. So log in back for that, because you're not gonna double dip for GCSAA education points for the 2 hours. So for all our sponsors of the Turf Center, thanks especially to the Michigan Turfgrass Foundation for all their support in funding during a challenging year also. And for those of you that might be attending the golf field day, we will see you back here at 11 a.m. So thank you for attending.